Hello, 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 hello. Okay, I'm not like in the best suit today, but I want to discuss or talk a little bit about probability today. And our goal, our objective of today is like starting this new year with some ideas of probability and remember, like getting in track for our studies in mathematics. So the objective of today, we're going to talk, or I am going to talk about some basic ideas of probability, bearing in mind that we are talking about mathematics in the channel, and we're going to see about some basic ideas that you're gonna need in the future. So uh, everybody must have right now an idea of what is probability, and we're just going to discuss some key features about probability, and we're going to talk about how to understand some calculations using probability. This is the idea of today. This is the idea we're going to work out. I want to check out that the chat is open. Let's see if I can sign in quickly. No, I think it's gonna take me time. Let's see if I can do it without any problem. Otherwise, I wouldn't write in any chat. No, I prefer to not to write a message here. No. Okay. Okay, let's see if I can enter here just to see if we can start. Okay. Meanwhile, you can think of what ideas of probability we can use to work out on let's see. Okay. Oh my God. Okay. Okay, I hope there's no problem with this. I'm just going to close this idea. We're going to start now. And the idea of today is we're going to talk about probability. So just for you to know that the first 4 minutes is just me doing nothing. So don't worry. I just need to organize something. As you can see, I was in vacations as well. So I just wanted to enter here. Let's see. Hello. Okay, that's it. I'm not going to focus more about this. Okay, so the idea is to talk about probability. We're going to see what is probability. We're going to discuss some ideas of basic probability. And the first thing that I want that you go when you talk about probability is that you imagine or think that there are things that may or may not happen. So the first thing you need to work out, or the first thing you need to focus on, is that, or is the fact that there are things that may or may not happen. So when you have things that may or may not happen, what we're talking is that there's a chance of something to happen. And if you have a chance of something to happen, then we talk about probability. So probability is just the chance of something to happen. This is probability. So we talk about probability when we want to know, or we want to decide whether something is about to happen, and we want to discover what are the chances of this to happen, okay? Or what are the possibilities of this to happen. Now the question is, first thing you need to ask yourself is, how can I call these ideas of something to happen? Okay, how can I call them? I can call them, or how can I decide if something is going to happen or not? Now, in this case, we're going to use the definition of probability. So the probability is just this, is the chance of something to happen. Of something to happen. You know, this thing of coming back from vacations is going to be wild, because I need a lot of stuffs, and I thought I have them everything together and I don't have. So I need to like change a little bit what I was thinking to do, but there's no problem. Let's see if I can use text or some idea here to write. No. Okay, so the idea is probabilities every time, or the probability is going to measure the chances of something to happen. Okay, so we're going to use we're going to use this idea to know how you can determine a number that tells you the probability of an event. I'm without pencil now. Let me see if I can find the way to write. The proper way to write. Give me a minute. Let's see if I can find solutions here. Meanwhile, we are working. Yep. Okay. Welcome from vacations, people. Now I solved the second problem of today. Now everybody, so the idea is that, as I told you, probability is the chances of something to happen. And if I want to know the chances of something to happen, probability, so it's going to be chance, opportunity of something to happen. But in mathematics, this thing of something to happen that may or may not happen is calling an event. So we call an event for everything that tells you or that may happen. So that's an event. And the probability is going to measure the opportunities or the chances of this to happen. Now, these chances goes from impossible, it's impossible of this event to happen, or certain, is completely certain of this to happen. You know, for example, let's say that we're going to roll a die or a dice. You're going to roll a dice, and so there's a chance that you get a number, right? Because when you roll a dice, you're gonna get a number from 1 to 6. So it's completely certain that you're gonna get a number. But if it's a regular dice, it's impossible that this number will be 7, or it's impossible that this number will be a negative number. So we know that there's an opportunity that goes from impossible to certain. And we have to decide this in terms of mathematics. So we need to convert it into numbers. So how we do it? We say that impossible is 0 or 0%, and certain is going to be 100%, or if you want 1. So the probability is going to be a number between 0 and 1. Okay? 0 is going to be impossible. So every time you see that, there's a chance of this to happen, and someone tells you that it's 0%, is telling you impossible. And 100% means certain. It's going to happen. It's gonna happen. And in between, so we have all the numbers. For example, in between we have 0.5 that we call it even chance, or 50%. That's what we call even chance. We also can have any number greater than 50% and close to 100%. That is what we call likely. That could be very likely or likely. And on this part, we're gonna say it unlikely. That is less than 50%. That it could be very unlikely when it's close to 0% and unlikely. You know, and we use it every day, these chances, for many things. Most of the things that we calculate are that we think, and most of our decisions are taken using probabilities. When you take a decision, usually your brain is thinking in terms of probability. What's going to happen in the future? What's going to happen if I do this? So this is how you can get the probability. Now, here is the thing. There are two ways to calculate probability. One way to calculate probability is that you think in terms of the conditions. All of these, you can think in terms of the conditions that you have. And using the conditions, you get the probability. This is what we call theoretical probability. Okay, so we use theoretical probability when you want to focus on the conditions. When you use the conditions, you use theoretical probability. But when we talk about measurements and we calculate this chance using measurements, we talk about experimental probability. Experimental probability. So we have two options to calculate the probability. The first one is by using the conditions of the experiment that you have, and the other option is that using measurements you determine the chances of something to happen, or the probability of the event. This is calling experimental. Experimental when you're taking measurements and you want to know what's going to happen, and theoretical is when you observe the conditions, and using the conditions you get the probability, and the probability using a number from 0 to 100. So I'm going to give you an example, the basic example that we can do using, let's say, okay, I'm going to do this example. I want that you imagine that we're gonna roll a regular die. Okay, so I'm going to try to do my regular die. Experimental and theoretical probability. and experimental in minute 12. Example, minute 15. Okay, now we can do the example with a regular die. So I'm going to put a regular die or a regular dice. Name it in the way you prefer. So let's imagine a regular dice. I hope that you know that a regular die, if you observe a regular die by front, it's going to have 1, 2, 3. Here on this side is going to be 4 to complete 7. Here on this side is going to be 6. And here on this side is going to be 5. You know, this is a regular die. And I'm going to roll this regular die. I'm going to roll it a number of times, or I'm going to roll it once. Okay, so I'm going to roll this regular die once. And I want to know the probability that the die rolls 4, for example. Now, if I assume that this is a fair dice, I assume that this is not going to have like the weight in a way that I can discover a number more than the others. I can tell that the chances that I have to get 4 is 1, because there's only 1 4 out of 6 faces. So it could be, when I roll the die, it's gonna show you one of the 6 faces, right? And one of these faces is going to be 4. So the probability of rolling 4, let's use appropriate notation, probability of rolling 4 is going to be 1 out of 6. Okay, so this is a fraction between 0 and 1, right? So this will be the probability that I roll 4, right? Now, let's say that I want to know the probability that I roll an odd number. I want to know the probability of rolling an odd number. So if I want the probability of rolling an odd number, so I know that the odd numbers here are 1, 3, and 5. So there are 3 possible outcomes that are going to be odd numbers. So the probability of being odd is going to be 3 outcomes over the total number of outcomes, that is going to be 6. So if I simplify, it's going to be 1/2. And if I want to put it as a percent, it's going to be 50%. So as you can see, the probability of being odd is even chance. There's an even chance that I got 50%. What means this? It means 50% means that I expected in an ideal world that if I roll it 10 times, 5 times I got an odd number. In the case of rolling 4, what is the ideal case? The ideal case is that if I roll it 6 times, I'm gonna get 4 only once, you know? This is theoretical probability. I'm using the conditions of the experiment to calculate. In plain terms, calculating the probability, the theoretical probability of an event E is going to be just the number of outcomes that corresponds to E divided the number of total possible outcomes. Okay, this is how you can calculate the theoretical probability. So you can calculate the theoretical probability by using the conditions of the experiment. In this case, I'm not going to roll the die. But what I'm going to do is just, using the information that I have, get the chances of the event to happen. So I know that the 3 faces are odd out of 6 faces, so I have 50% of probability of rolling an odd number. I know that from the 6 faces, 1 is 4, so I need to take 1 out of 6 is going to be my probability. You see, and this is how you can convert every aspect, or you can convert any probability or calculate any probability in terms of theoretical probability. Now, what will be experimental probability with the same problem? Experimental probability with the same problem. experimental probability will be that I'm going to perform the experiment a number of times. I'm going to perform the experiment a number of times. And I expect that if I run the experiment a number of times, I'm gonna get my experimental probability. Okay, so I'm going to do the experiment. I'm gonna put here, let's see if I can go to Google here. That's right. And I'm going to put here in Google, I'm gonna tell Google, hey Google, regular die rolling, virtual dice roller, look. So I'm gonna get here a virtual dice roller. Here it says 2, no, I just want 1. That's it. And I can roll the die here. Okay, so as you can see, for example, the first one is 5. I'm going to take notes of the scores, the results, right? So I'm going to write on a paper the results. I suggest you to do the same. I'm gonna do this example rolling 10 times. So the first time is going to be 5. 5. Roll dice. Second is going to be 2. So as you can see, if I want to calculate experimental probability, I need to roll the die or roll the dice many times. I need to perform the experiment. This is why it's called experimental probability. Here we have 4. Another 4. I rolled 5 times. 1. 2. 6. I suggest you to do this experiment by your own with a regular die and get the answers. So I'm going to show you now. I'm going to the board to show you what I did. I just already take 10 times. I just rolled the die 10 times to see what happened. Okay, so I just roll it 10 times, and if I want to get the experimental probability, now what I suggest you when you want to calculate the experimental probability is not to take only the data, but identify how you can organize the data correctly. So I recommend you to use a table. For example, in this case, I'm going to roll a regular die. So the outcomes or the events are 1, 2, 3, 4, 5, and 6, right? And now I'm going to put in my table the frequency. So the frequency is going to be the number of times that it appears the number. In this case, I only rolled 1 once. I rolled 2 twice. I didn't got any 3. I rolled 4 2 times. I rolled 5 4 times, and I rolled 6 1 time. You see, and this is your frequency. So you have the frequency, and using the frequency, I can calculate the relative frequency. And the relative frequency is just a relation between, or the ratio between, the frequency and the total number of trials. In this case, the total number of trials was 10. I did it 10, so I just need to multiply by 10 this number to get it in terms of percent, right? So if I multiply by 10, I'm gonna get it that the relative frequency is 10%. In this case is 20%. In this case 0%. In this case 20%. In this case is 40%. And in this case is 10%. Now, the experimental probability is going to be the same as the relative frequency. So if you calculate the relative frequency of an experiment, you're calculating the experimental probability. Here is what happens. Here is the relative frequency, and in the relative frequency we have the experimental probability. Now, here is the thing. So, for example, here the experimental probability. I want to know the experimental probability of rolling 4. I know that the theoretical is 1 out of 6, right? And in this case, the experimental probability of rolling 4 is 20%. Now, 1 out of 6 or 20% is just 1/5. So look at that, it's not the same. But if I convert 1 out of 6 to percent, 1 out of 6 to percent is like 16.66. Okay, I'm gonna round it to 2 decimal places. Rounded to 2 decimal places is going to be 16.67, right? And I also calculate the theoretical probability of being odd. So in this case, being odd is going to be the probability of 1, 10%, plus being 3, 0%, plus 5%, 40%. So I got 50%. And if you remember, the theoretical probability of being odd was also 50%, even chance. So look at that, this probability are the same. And this probability, even that is not the same, 20%, even that is not the same, is close to 16.67. Okay? And this is when we talk about what is the relationship between the experimental and the theoretical probability. When you have an experimental probability and a theoretical probability, what is expected is that the more you do the exercise, the more you work out the exercise, the closer must be the experimental probability to the theoretical probability. So in plain terms, as a main idea, something that is good that you remember, the theoretical probability will be just the experimental probability when we perform the experiment and infinitely many times the experiment, okay? When you perform the experiment infinitely many times, you have the theoretical probability. This is what is expected when you work out with theoretical and experimental probability. Now, from now on, you can work out on calculating many events, on organize many events. For example, there are some things that are calling mutually exclusive events, that are events that cannot happen at the same time. For example, in this case, the probability of getting 4 is a mutually exclusive event. The event of rolling 4 is a mutually exclusive event with rolling odd. Why? Because 4 is not odd. So it means that if I got 4, it's not possible that I got odd. Those are mutually exclusive events. For example, rolling 1 and rolling odd, they are not mutually exclusive events, because if I rolled 1, I'm rolling an odd number. So they are not mutually exclusive. Mutually exclusive is if I roll 1, I cannot get the other. In this case, rolling 4 is mutually exclusive to rolling odd, because if I got rolling odd, I cannot roll 4. This is the main idea of probability. And these are the basic of probability that I want to discuss with you, that I want to do in this video, that I want to show you. That is simple. It's just how we can identify the chances of something to happen and how to work it out. My recommendation, my idea, my experiment that I would like that you comment in your in your social media. Rains or doesn't rain? What is the probability of rains here in your country or in your city? How can I calculate it? How can I know it? How can I know this probability? Can I use experimental probability? Can I use theoretical probability? That's the idea. For example, if you start studying the 1st of January, here in my country, here in my city, I had here in my city, I was just bearing in mind we just 6th of January. 1st of January didn't rain. These 3 days didn't rain. And these 3 days rained. So far, if I calculate the experimental probability of that tomorrow is going to happen, so I either say that is even chance, right? Because 3 days, 3 days rains and 3 days didn't rain. So why don't you start working on your probability of raining during this month and calculate it, and let's talk about it. See you in the next video. I hope that today we learn a lot about probability. You learn about the basic definition of probability, basic definition of theoretical and experimental probability, and that you understand how to calculate them, theoretical and experimental, and about mutually exclusive events. That was the idea of this video. I hope that you like it. I hope that you can work out more on probability, and see you soon. Bye bye. Bye bye, everybody.